In this lab, we're going to look at BigQuery Soccer data analytical insights. So the overview here is, in this lab, we will learn how to analyze the soccer event data using various BigQuery features, write and execute query that work with nested data in BigQuery tables. So first of all, we go to open the BigQuery. Alright, so you will find the following dataset, soccer, insight. These are the tables that we will use later on in our query. So in the task 2, we're going to analyze the nested soccer event data. How do you query the nested data? Okay, so we can take a look at the events table. So you can see this one, the text is a record data type, and this is the nested data. I'm going to run this data query now. So you will run this query using the array functionality to enable better control over the soccer event data. So this is done by using the correlated cross join between the events and the text field with the comma in the from clause to represent an implicit join to create one row per tag per event rather than one row per event. The tag ID that correspond to assist is found from the text to name table. The number of occurrences of the tag is counted by the player, and the players table get player names from their ID. Okay, so there are 3 tables here: events, text to name, and players. So for the name come from players, and then the label come from text to name, and the player ID is from the events. Okay, so when I run the query, this is the result. Okay, now move on to the task 3. We use a new window. Calculate the average pass distance by the team. This section we will run some query that use nested field in the soccer event data and the BigQuery array functionality and structured data type to answer some interesting question. So what are the questions? How much do club members differ in terms of average distance on their passes, both overall and accurate one? So to answer this question, you need to study the position field in the events table. Observing this data, you see that this is repeated field that contains one or more X and Y pair per event. Okay, from the data, you note that okay, so this is how the data looks like in the event table. You will notice that the passes have 2 attributes X and Y pair representing the start position and the end position. Okay, you have these different positions here, 63, 39 for one particular event. Okay, so now I use a new window to open and run this query. Not sure if you can see, I try to zoom in a little bit. So this result returns to shows you that which team from which country, the number of passes, and then the average distance they pass, and the accurate pass distance. The pass distance is calculated by extracting the initial and final X and Y axis coordinate using ordinal function and applying concept and formula mentioned above. The final select statement here aggregate the passes of the data to the team level, filtering only on the club member. Okay, so which is this one? So in this section, the BigQuery was used to determine the number of passes and the average distance of passes by the team. To achieve this, you use array processing capability to extract repeated value in a single field, then calculated the distance between the starting and the ending point of each pass. In the next session, you will learn how to harness other coordinate data to generate information about the short distance. So in the task 4 now, we are going to analyze the short distance. We will straight away run the query and just straight away see the result. So as per the previous query, the approximate dimension of soccer field are used with the x coordinate and y coordinate distance input to the distance formula. So the initial width clause filter the event to shots only. Okay. Adds an isGo field by looking inside the tag. And calculate the short distance the same way that passes the distance was handled in the previous section, but use the midpoint of the goal mouth 150 as the ending location. The final select statement aggregate the number of goals and percentage of goal from shot by distance rounded to the nearest meter. So as expected, the shot at close distance have much higher goal rate. That is logical, I think. Yeah, of course, when you are closer to the goal, I mean, the chances of getting the ball into the goal is higher. Now I go to the chart and take a look. Okay, you can also change the chart to other different type, like I changed to scatter. So there's a slight bump here in the success rate of 11 and 12, but they can likely be explained by the fact that the penalty kicks, which are by design much higher proposition than most other shots, account for a large percentage of shots from that range. So if you have a penalty kick, you will have more chance of goal as well. Okay, the task 5, we will analyze the shot angle. In this section, modify the previous query to look at the impact of angles on shots. Okay, so in this diagram, I like this diagram because it's very easy to understand. So the larger angle arises from being close to the goal and in the center, so this is somehow correlated with the distance calculated performed above. The short angle calculation involved, you will use the BigQuery trigonometric functions. Okay, let's place this and run this query now. So the mathematics here is getting very overwhelming now. So you see, if you want to know which angle actually give you the most percentage of goal, is these are the angles. There are 5 of them here. So the query is similar to the short distance of the one that we see previously. To extract the short coordinate to simplify when needing them multiple times in the angle calculation and a more detailed trigonometric calculation using the law of cosines. Right. Okay. To click, so I already run, and your short angles seem to be generally positive, correlated with goal success rate, going from single digit success rate at angles below 20 to a much higher rate, wider angle, with relative lower sample size beyond 60. Okay, let's look at the chart. Okay, so the chart here, up to you whether you want to change it to other chart type. The plot shows that the relationship between short angle and success rate is relatively linear up to about 100 degree. Again, the widest angle are only possible on shots close to the goal. So some of this is correlated with the distance effect shown above. There is a slight bump up in the success rate of 35 and 38, as these are the most common shot angles for penalty kick. Again, a higher proposition than most other shots, and account for a large percentage of shots from that range. Yep, thank you so much for watching. We have completed the lab.